right, section 2 of chapter 13 is still about counting, but we're going to get a little bit fancier. In our counting, we're going to learn about combinations, which can be written either like this. So big C in the middle with a small n and r subscript. Or your book kind of likes this way with a big C and then the n and r in parentheses. Or as we learned in our last section, like this, with just the parentheses and one top and one bottom. All the ways we can write a combination, just like in the section we've already done, the formula for that is n factorial over n minus r factorial over r factorial. So we have this little formula that we can just plug numbers into. They're going to give you the n and the r. You just plug them in. You probably have a button on your calculator, and it most likely looks like this in the probability section. It might look slightly different, and I will even be glad to help you find it if you can hold your calculator up to a camera, and I will help you find the place that it's located there. So, combinations, plugging numbers in, permutations. A permutation is written either like this. Notice the similarity. It's the big P this time for permutation with the small n and r subscript. Or another way, the way your book prefers to write it, is the big P. In the calculator, it's probably going to look like this. If you have a permutation button in your calculator, it probably looks like this. And the formula for this one is n factorial over n minus r factorial. Okay, look how similar they are. The only difference is this extra divisor right here, this extra thing that it's divided by. So why is that there? It's here because a combination order doesn't matter. And here in a permutation, order does matter. So, if you drive up to the drive-thru at Taco Bell and you ask for 3 tacos and a burrito and a Pepsi, the order that you say those things doesn't matter. That combo meal is short for the word combination, and it doesn't matter the order that you say it in. So combination means that the order you say it, if you open your bag and you see a burrito and 3 tacos, that's the same as seeing 3 tacos and a burrito. It doesn't matter what order you say it in, what order you see it in. It's the same thing in the bag. A permutation, on the other hand, order does matter. So here you're going to think of the first, second, and third place winner in a race. It matters whose name is said first and whose name is said second. Whereas a combination is more like if we have chosen a committee. Here are the people that will serve on our committee. The order we say the names doesn't matter for practical purposes. Your feelings might get hurt if your name is said last, but it doesn't matter which order they're said. We have the same combination. In a permutation, the order does matter. Because of that, something extra has to be divided out, because there are going to be less combinations. Because in a combination situation, an apple, an orange, and a banana is the same as a banana, an orange, and an apple. They don't count twice. Whereas a permutation, order matters. So those are 2 different things. That's why we have an extra thing divided on the bottom, because this number must be smaller because we're not counting as many things as individual choices. And these are both really about counting. That's what they're about. We're counting the number of ways to whatever, because we can't find the probability something will happen until we know how to count the total number of ways something can happen. So we're basically going to do these in a calculator. You almost certainly know how to find your factorial button. It's worth the time to find your permutation button. They can be done by hand, and we already practiced this in the last chapter, so I'm not going to do a bunch of examples of this. But I want to point out that for both of these, there are no repeats. So, if we are given a list of things to choose from, they can't be reused. So, if I say to you that we are going to choose 3 people to be on our Mu Alpha Theta committee, I can't choose Preston and Preston and Preston. There's no repeats allowed. I have to choose 3 unique people on my committee. If I'm choosing a president, vice president, and secretary, the order matters. That makes it a permutation. If I'm just choosing a committee, it's a combination. But if I'm allowed to repeat and use the same thing over and over again, then that's something completely different from me. So how do you do one that has a repeat? Well, it's going to be called a permutation with repeats, and here's what that formula looks like. So it doesn't get a shortcut. There isn't a cute way to shortcut this in your calculator. I wish there was. But you're going to be able to do the factorial part in your calculator. So when we have repeats, we have n over, and then we kind of put like this. This is n1 factorial, n2 factorial, n3 factorial. So let's talk about what this means. So here, the n, the thing that comes first and that goes on the top, that's how many you have to choose from. There are 30 people in our class, and I'm going to choose 4 to be on my committee. Order doesn't matter. This would be 30 and 4. That's where the numbers go. The big number on top, the smaller number on bottom, and it will be a big and a small, because if you have 30 to choose from, you can't choose 31. So the number on top is how many you have to choose from, and the number on the bottom is how many you're going to choose. That's why we usually read these 30, choose 4, in case you were wondering why we write it like this. 30, choose 4. So the n is the number you have. This is how many you're going to choose. If I'm going to choose from a committee, I'm going to choose a president, vice president, and a secretary. Order does matter this time. Here's my 30. I have 30 kids to choose from, and I'm going to choose 3, but this time order matters, so I have a P instead. So this is still 30 permutation for the n on top. That's our big number. And then here is going to go, here you have your big number, your small number, and the difference. Here you just have the difference. But your n is going to be your big number. Your r is going to be your smaller number, the amount you're choosing. So what does it look like with repeats? That may mean that we're going to choose somebody to be the president for a day today, and then someone to be the president for a day tomorrow, and it can be the same person over and over again if we're allowed to have repeats. Or maybe we're going to be choosing, say, from girls and boys. So we're allowed to have more than one girl or more than one boy. So what that means, and a really common one here, is talking about how many ways there are to put in order. Because remember, this is a permutation with repeats where order matters. This is everyone's favorite example. How many ways are there to order the letters in Mississippi? So order matters, but we are going to have repeats because we're going to have more than one S and more than one I. So here, how many do we have to choose from? M-I-S-S-I-S-S-I-B-B-I, 11. And how many different categories do we have? That's going to be, these numbers down here are going to be, well, there's one M. There's going to be I-S-S-I-B-B, 3 I's, and so on. So that's when we have little groups that we're allowed to repeat. That's those numbers down here. So this is the formula when there are repeats. What they're usually going to give you here is something like, I have 30 socks in the drawer, and there's going to be this many green and this many red. They're not usually going to ask you to count it out. Okay, so what if our R is 1? What if there are 30 kids in class, but I'm only choosing 1? How does that affect this? Well, the way it affects it is that it gives you a 0 factorial on the bottom. And remember, we said that was defined as 1, but what we really do, if we're only choosing 1, is we just do the factorial. So if we're choosing 1 at a time, so 1 at a time might be, how many ways are there to put 20 students in a line? Well, I'm going to choose one kid for the first spot, and one kid for the second spot, and one kid for the third spot. So I have 20 choices for the first spot. I only have 19 choices for the second spot because this kid's already been chosen. In the third spot, I have 18 choices because 2 of the kids are already standing in line. And so on, which is just 20 factorial. So when we're choosing one at a time from some group and we're going to use them all, so we're choosing one at a time and we're going to use them all, we're just, how many ways are there to order whatever, then that's when we use our factorial. So that would be kids in a line is a really popular example, but also books on a shelf. How many ways are there to arrange these 15 books on a shelf? I'm going to put one at a time. When I put the first book on the shelf, I have 15 choices, but when I put the second book, there's only 14 choices because I've already put one of the books on the shelf. So how many ways are there to order 15 books on a shelf? 15 factorial, that's how many. Now, what we were doing before is about how many ways are there. If I have 15 books, how many ways are there to put 3 on the shelf? So I'm not doing them all. I'm choosing a group. Those are our combinations and permutations. So how many ways are there to take 6 kids from a class of 20 and put them in line? And if you've ever tried to put some young kids in a line, you'll know that order does matter, so it's a permutation. If we're putting them all in order, then we're using up everybody, it's just a regular factorial. If we're going to choose some from the group, that's either a combination or a permutation, depending on whether or not order matters. There's one last thing they ask us to count, and I think this one is the most familiar, so I think most of you are going to have an easy time with this one. If you have 3 shirts, there's a chance you have more than that, but let's pretend. 3 shirts and 5 pairs of pants, and then you've got, I don't know, 8 pairs of shoes. How many different outfits can you choose? You have 3 choices of shirt times 5 choices of pants times 8 choices of shoes. Those get multiplied just like we did before because we multiply our choices together like that. So whatever this answer comes out to, 120, that's how many different outfits we can make from this. If you have 6 choices of main course at the restaurant and maybe 5 choices of a side dish and 2 desserts, how many different combinations of meals are there? Well, there's 6 times 5 times 2 because I have 6 choices for this bit, 5 choices for this bit, and 2 choices for that bit, and that means there's 60 different meals that we can make. That one should be pretty familiar. This is different categories. So the first part, again, is when I have one category, students, and I want to do something, I want to choose some amount of them. I'm going to choose 5 of 20. I'm going to choose 4 of 20. Those are our combinations and permutations. A combination order does not matter, just like at Burger King. A permutation order does matter. If we're going to do one with different little categories, that's the one that's called a permutation with repeats. We don't use that one too much, but it exists. Then we have the bit where we're going to use everybody. That's just a regular factorial. And then last, what if it's totally different categories? It's not 30 shirts and I want to know how many different ways there are to choose 5 to wear this week. It's 3 shirts, 5 pants, 3 totally separate categories. So that's when we multiply the amount in each category, like so. Okay, there's section 2 of chapter 13. I will be glad to answer questions with a chat or a phone call, or I will upload a video answering your question. If you'd like to email it to me, you can, however you can find a way to send it to me, write it down, take a picture of it, and I'll read your question that way. So send me all your questions, but we will have a meeting again before too long for you to ask them live.